the shift register application. And for the shift register application, I'm going right to the answer keys here. I've opened up the Word document already in Teacher Resources, but there is one thing I want to show you here. There are two multisim files in the answer key here. The first multisim file is for the Design tab, and you kind of see it right here. It says Design on it. The second one is for the DMS, and when it means the DMS means obviously your CMOD or a PLD circuit there, and that's the one that I have open that I'm going to be talking about here. So first of all, we're going to go to the Word document to look at this last activity in here for the students on flip-flops. And one of the things that's interesting is, you know, we're into PLDs now. You did your date of birth, your number 2 date of birth on a PLD. And from here on out in the course, we use PLDs. Now, of course, it's up to you. If you want to build stuff with TTLs and have the kids go through that, that's fine. But at this point in time, I put away all my IC chips, and they're gone till next year when we start this over again. But in the activities, they reference the regular IC chips that we'd use on a Design tab. For example, this circuit that I'm showing can only be built on a Design tab because it's got a 7-segment display up here. If you take a look closely at the flip-flops, they have 1s in front of them, and then the second one has a 2. Well, these 2 are in one IC chip, and that's on the Design tab. You know, they got the little identifications up here, preset, J, K, clock, and that. But they got numbers in front of them, 1 and 2. Well, 1 is the first chip in the first JK flip-flop in the IC chip, the 74LS76, and this one's the second one in it. The other thing is, you notice they got switches out here, and you can't have switches in a PLD. So the kids can build this. What's nice about it is up here they've got an output. Instead of, you know, looking at the binary numbers, they can look at this. And if you look at this, this is not a normal 7-segment display. A 7-segment display has 7 wires to it for each of the segments, A through G. This one only has 4. What happens is this has a BCD to 7-segment decoder built into it. So it's kind of cool. You don't need resistors. You hook up your binary, your 4-bit binary to it, and it'll display in hex. It'll go from 0 all the way to F. So it's kind of a cool little tool so they can see it. Now there's something extra added on to the shift register here. Normally, you know, the shift registers, the JK flip-flops, down here they've got a little extra circuit. And we talked about that in the actual PowerPoint. And I guess they're using 2 input AND gates here because that's what we, you know, tell students to use at the beginning of the year, because that's the ICs that we're limited to. But, you know, since we're in a PLD, we can actually have a 4 input AND gate down here. You're going to see this as we go further down. But what happens is this guy's looking for a certain pattern. The pattern must be D. So if we take a look at it, here's the most significant bit. In here, the least significant bit. So we're shifting into this flip-flop, which is the least significant bit, the data. There's our data coming in. Here's our clock. This particular clock is a falling edge because we got the little not symbol or active low symbol on there. So this is a falling edge one. And as we shift the pattern in and make a D, which is a 1, 1, 0, 1, there's a D. Down here, we detect that D is in the shift register. So this is kind of a detection circuit, event detector. It's detecting the event of a D loaded into the 4 registers, or the 4 flip-flops. If we take a look at it, these ANDs, in order to get a 1 out, remember we got to have a 1, a 1, and a 1, and a 1 on all of these to get a 1 out to light that probe up. So we look back here. So here, this is a 1, so we're on the Q output. This is a 1, so we're on the Q output. This is a 0, and the only way to get a 1 out of that, we tie it to the Q naught. So that's why it's connected to the Q naught. So it gives us a 1 when this guy is a 0, because that's what we're looking for in the event. And we go back here to the last one. This is a 1, because that's what we're looking for. We're tied to the Q. So that's the setup of that circuit right there. So, you know, the students can build this one in Design tab, and they can play around switches and the 7-segment display. So that's what they have them do. They have them look for two different sequences. Here's 1101, which is that one. Then they also have them look for 0110, which is a 6. So that means they got to change these connections. It's the same flip-flop connections, but they got to change these down here. So those are the two little activities we work on. All right, now they switch gears and they go to PLD mode. Now, if you take a look, this PLD JK flip-flop doesn't have the little 1 and the 2 in it, because this is the way they're shown in the when we pull components out for building a PLD circuit. It's different than these up here. You can't copy from a design tab and paste it into a PLD, so they got to rebuild this circuit down here. And this particular circuit is looking for, looks like again 1 1 0 1, so it's looking for the D again up here. And then they say make the necessary modifications, have it look for a 6. So they look for a D and a 6. And this is one where they're going to download to the DMS and the CMOD and use the actual physical hardware switches on that. And this is where you're going to run into contact bounce. And where contact bounce is going to happen to you. Now, just this last week, my students are doing this right now. Just last week, I had one student, he loaded this in and he hit the clock here with the push button, and he said, well, it was working before, and he just clocked 1 straight across, so all the flip-flops got set to a 1. And then he changed it to a 0 and clocked all zeros across there. He says, okay, so what you're going to need now, this is what I talked about in class, contact bounce on these switches. And lo and behold, I turn around to show him it on the bulletin or on my chalkboard, and he goes, there I go, I got it. Oh my goodness, so he clocked it in. So he pushed the switches, didn't get contact bounce, and got the pattern in. So anyway, he was successful. So he did evidence contact bounce. So you're going to get contact bounce on this C contact right here, the clock contact. And I think I talked about that in the PowerPoint, but when I went through that with you. So if not, you can look up contact bounce on switches on the internet, do a Google search, and they'll have a good explanation of what it is. So. And you may see this on your DMS board. It depends on how they're used, how old the switches are, you know, if they've been used a lot before. All right, so let's switch over and we're going to take a look at the multisim file. So here's the multisim file that they give you. Once again, okay, we got this right here is called a digital high. This is like our VCC whenever we want to tie anything high. This stays with the PLD when we transfer it to a CMOD, so this does not go away, so it doesn't disappear. This is an interactive switch, and this does go away. This disappears, and then you got to actually hook your physical data switch that's coming in right here on PIO 45. Same here, this one right here is interactive digital constant. That's the clock they're using to simulate to test the PLD. This will go away when it's downloaded. All these probes go away. Looks like they've got these hooked to the LEDs on the CMOD, which is, there's no problem with that. And then they have this is coming out of PIO 36, and you would wire PIO 36 to an LED on the DMS. Remember to have your MIDAC connected, because if you don't have your MIDAC connected, your switches won't work. The LEDs will work, but your switches won't work. So you got to have your MIDAC connected and that USB cable plugged in. Let's see, anything else here? Yeah, make sure, sometimes the students, this is a problem, when they add a connector, it comes in as an input connector. So I'm going to double click on this. I'm going to change it to an input connector so you can see what an input connector looks like. So yeah, when they assign it and build this circuit, this thing comes in as an input connector, so they actually have to click on it and make it an output connector, because otherwise it won't control this when we find the event LED that you got this wired to. So I'm going to double click on this again, make that an output. So that's an output. So it looks like everything's set up. Oh, another key thing. Anytime you have a pin that will control a clock, CLKs, 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 Anytime, it must come in on PIO 14. PIO 14 is a special input pin. It's a clock pin. If you put some other number in here, if you put PIO 43, when you do the transfer down here, you're going to get an error. And if you go looking back up through the error message, it's something about a clock phase signal, but it has to be a PIO 14. There are other clock pins, and if you need them, we can always give you that information. So let's take a look at this. Now, let's see. This guy says it's looking for 1011. So let's check it here. 1. And look at here. We got a 4 input AND gate down here. Oh, look at this. Looking for a 101, right? Yeah, because there's a little dot right there. So it's not, so this is wrong up here in the answer key. It should be 1101. Somebody's got this backwards. So let's start our simulation. And the clock edge here means it's going to be when the clock goes to 1 to 0. So right now the clock is at 0. And the data coming in is a 1. So I want to clock in 2 1. So I'm going to go 0 to 1, back to 0. So there we go. We brought in our first 1 into this flip-flop. Then we're going to clock it again. So we go to 1. Now the second data bit coming in. So now we collect two of these in. And now to make the pattern, I got to make this a 0. The data is 0. And now what I can do is I can change the clock. And then the last one is a 1. And there we go. My circuit works. So now we could download this to our CMOD. We can wire switches up to here. Now I want to show you something else which you can add on here. Besides that, we could actually put a physical clock down here. And I'm going to stop simulation. I'm going to go up here to place a component. And we're going to go down here to, let's see, I think it's sources, digital sources. Yep, right there. There's our digital high, there's our digital low. So this is VCC and that's ground. So those will stay if you put them in your circuit. Remember, this is the interactive digital constant. When it's downloaded, it's forgotten about. So got to have a pin connected to it. So here's our digital clock. So we'll take our digital clock and I'm going to put our digital clock right down there. Say close. I got to get rid of this. I got to delete this guy. Because I can't have two outputs connected together. So now I'm going to put a clock in here. If I had my options turned on, let me see here. Sheet properties. If I had these guys all turned on, we could see. Let me see that. Yeah, so we can see that this is a 1 kilohertz clock. Now that's way too fast for us. Way too fast. So I'm going to change this to a 1 hertz clock. So double click on it. Change the 1K to a 1. Say OK. Now I got a 1 hertz clock here. Now, when you download this clock is going to disappear. It's not going to be in here. But I need it right now because I don't have a clock in here. So now I'm going to run this with a clock. And I'm going to leave this switch at a 1. So you'll see it just kind of clocks 1s all the way across. Alright, so now I want to get my pattern in here, so I need at least a 0 in here. So I'll change my data. I got my 0. Now I'll put it back to a 1. There's my pattern. It detected my pattern. Now the clock pulse is going to change and my pattern went away. So what you can do with your students, if they're running into switch contact bounce here, putting a switch on PIO 14, you can always hook up your digital writer on your MyDAC and get the slowest little count coming in there, and then they can have a switch for this. And that's what I do to have my students demonstrate this. So, but anyway, that pretty much wraps it up for this this activity here. And it's pretty simple, pretty straightforward. I think I've talked about all the little issues with this thing. Once again, I just want to stress, stay away from the push buttons that are mounted on the CMOD for static. Use the push buttons on the board. The other thing is make sure your CMOD USB cable is unplugged, and also your MyDAC is unplugged, so there's no power to the CMOD or the DMS board. As for example, when you're wiring in this indicator over here or wiring switches in or something, you don't want to have power applied to it. So that's a good technique here to help you save your static sensitive CMOD devices. So, all right, thank you.